What's up viewers? This is Sherma TV. So ang topic natin sa video na ito is analysis of doubly reinforced beam using NSCP 2015 provisions wherein the compression steel does not yield. So if you will remember sa previous video natin, so discuss natin doon yung analysis ng doubly reinforced wherein nag-yield yung compression steel. So sa video na yan, nalaman natin kung kailan kakailanganin yung bakal sa compression side at kung ano yung parameters in order to say na mag-yield yung compression steel. So in this video naman, so the scenario here is kabaliktaran nung previous video natin, in which dito hindi mag-yield yung compression steel. So tingnan natin, compare natin kung ano yung pinagkaiba at kung paano yung paraan ng pag-solve kapag naka-encounter ng ganitong situation. So let's start with the lecture now. So yung problem natin, binigay ito nung November 2010 sa CE board exam. So ito yung problem. A simply supported beam is reinforced with 428 mm at the bottom and 228 mm at the top of the beam. Steel covering to centroid of reinforcement is 70 mm at the top and the bottom of the beam. So this is 428 mm yung bottom, while yung top natin is 228 mm. So steel covering to the centroid of the reinforcement at the bottom is 70 mm, while at the top, so your D prime is 70 mm. The beam has a total depth of 400 mm. So yung H or the total depth is 400. So if we subtract 70, effective depth natin is 330 mm. And a width of 300 mm. So ito yung width natin, 300 mm. FC prime equals 30 MPa, Fy is 415 MPa. Balance steel ratio is 0.031. So ito i-verify natin to kung ito pa ba, since this was given during November 2015, malamang sa malamang ginamit dito na NSCP is 2001 version. So may nabago na sa 2015. So verify natin kung yan pa din yung lalabas. So number 1, determine the depth of compression block. So we refer to the value of A. So ito yan. Number 2, determine the design strength using 0.90 as the reduction factor. So MU. So ito i-verify din natin kung 0.9 pa ba yung dapat gamitin. Baka kasi hindi na yan based dun sa provisions ng code. Number 3, determine the live load at mid-span in addition to a dead load of 20 kN per meter, including the weight of the beam if it has a span of 6 meters. So sa number 3, so we are looking for the value of the concentrated live load LL for the beam. So simulan natin for checking if kailangan ba talaga ng compression bars or hindi na. So in order to say na needed yung compression bars, so we must satisfy the condition rho is greater than rho max. So yung rho natin is equal to AS over BD. So yung AS natin, yung total area of steel sa tension side. So we have 4 times the area, so pi over 4 times the diameter of 28 squared over B is 300 times D of 330. So pwede natin i-cancel yung 4. So, yung value ng rho natin will be pi times 28 squared kasi kinancel natin yung 4 over 300 times 330. So, yung rho natin is 0.0249. So, now, kunin na natin yung rho max. Rho maximum is 75% ng rho balance. So, now, let's solve for the rho balance. So, dito, balance to the ratio is 0.031. So, kung yan yung gagamitin natin, it will be 0.75 times 0.031, and that is equal to 0.75 times 0.031. So, that is 0.02325. So, kung titignan natin, mas mababa sa value nito. So, if we will use this, so we can say na needed talaga yung compression bar. But, since we have a new code or new version of NSCP which is 2015, i-check natin kung ito ba talaga yung raw balance. Kasi may formula naman tayo sa raw balance. Okay, since we have raw balance is equal to 0.85 FC prime beta times 600 over Fy times 600 plus Fy. So, yun yung formula natin for the raw balance. Now, since meron tayong formula, let's just do some substitution. So, ano ba yung beta factor natin? Since we have FC prime of 30 MPa, so, sa old code, kapag 30 MPa and below, so, automatic 0.85 yung beta factor. But since bago yung code natin, yung beta factor natin is ito. So, ayun sabi sa code natin. Yan. So, yung beta factor natin is 0.85. So, 0.85 minus 0.05 times the quantity of F prime C natin is 30 minus 28 over 7. So, we have a beta factor of 0.836. So, hindi na 0.85. So, magbabago yung raw balance natin. So, yung beta factor natin equals 0.836 as per NSCP 2015. So, yun yung mababago. Therefore, we have raw balance of 0.85 multiplied by 30 times 0. Not 835 but 836 pala. 0.836 times 600 over Fy natin is 415 times 600 plus Fy. So, yung raw balance is equal to, so we have 0.85 times 30 times 0.836 times 600 over 415 times 600 plus 415. We have 0.0304. 0.0304. So, yung raw max is equal to 0.75 times raw balance. So we have, multiply natin, times 0.75. So that is 0.0228. Okay, so 0.0228. So bumaba pa yung value natin ng raw max. So pasok pa rin. So yung raw natin is less than raw max. Therefore, need natin yung compression bars. So therefore, compression bars needed. Now, let's check naman if tension or compression still will yield. So, we have to satisfy this equation. So, we have rho minus rho prime should be less than 0.85 multiplied by FC prime beta times 600 times D prime over Fy times D times 600 minus Fy. So, pag nasatisfy ito, kapag less than siya, compression still yields. But, kung makuha natin na value is greater than dito, that will be, as kapag less than, compression still does not yield. Pero kapag greater than, compression still yields. So, kunin muna natin yung rho prime. So, yung rho prime equals AS prime over BD. So, we have 2 times pi over 4 times 28 squared over 300 times 330. So, yung rho prime natin is, so that will be 2 times, so pi over 4 times 28 squared over 300 times 330, and that is 0.0124. So 0.0124. So yung difference, rho minus rho prime is equal to yung kaninang nakuha natin, 0.0249 minus yung answer natin kanina na 0.0124. So that is 0.0125. So dapat ito maging less than dito. So by substitution, we have 0.85 times 30 times the beta factor na na-solve natin is 0.836 as per NSCP times 600 times D prime of 70 over Fy times D times 600 minus Fy. So, we have a value of, so dito natin ilagay, so 0.85 times 30 times 0.836 times 600 times 70 over 415 times 70 times 600 minus 415, and that will be equal to 0.17. So 0.167. So ulitin natin na. So that is 0.85 times 30 times 0.836 times 600 times 70 over 415. So this is not 70 but this is 330 pala. So mabuti yung check. So that is 330. So that is equal to 0.0353. So 0.0353. So 0.0125 is less than 0.0353. Therefore, compression still does not yield. So next, so since compression still does not yield, therefore Fs prime is not equal to Fy. So now we solve for Fs prime. So galing dito, so this will be your strain of the steel, so epsilon S prime. So by ratio and proportion, this is C, this is C minus 70. So we have, so epsilon S prime is to C minus 70. So ito tsaka ito equals 0.003 is to C. So masolve natin. So the strain of the compression steel is equal to 0.003 times C minus 70 over C. And then we also have Fs prime, so by Hooke's law is equal to the strain of the compression steel times the modulus of elasticity. So therefore, this one will be Fs prime equals 200,000 times 0.003 times C minus 70 over C, and that will become 600 times C minus 70 over C. So now, since this is a couple, so we have T1 and T2 is, so T1 plus T2 equals C or T. So if we equate summation of forces, T equals C1 plus C2. Here T equals AS Fy, while your C1 is 0.85 Fc prime AB, and your C2 is AS prime Fs prime. Since Fs prime is not equal to Fy dahil hindi nag-yield yung steel. So, ASFY, pag sinubstitute natin, will be equal to 0.85 Fc prime. So, yung A natin, then B plus AS prime Fs prime. Now, by substitution, pi over 4 times 4 times 28 squared times Fy of 415 MPa is equal to 0.85 times 30 times A times 300 plus AS prime is pi over 4 times 28 squared times 2 multiplied. So yung Fs prime natin 600 times C minus 70 over C. So yung A natin, pwede nating i-substitute as, so A is equal to beta C. So since yung beta factor natin is 0. Yung kanina, so that is 0.836. So sa the value of A magiging beta 1C. So that is 0.836 times C. So C na lang, yung C na lang yung R natin, yung variable. So pwede na tayo mag-input sa calculator using shift solve. So we have, so ito, cancel. So that is pi times 28 squared times Fy of 415 equals 0.85 times Fc prime times beta, so that is 0.836 times yung C, let's use X, times 300 plus pi over 4 times 28 squared times 2 times 600 times, so X minus 70, so yan yung value natin ng C over X. So check ulit natin, pi times 28 squared times 415 equals 0.85 times 30 times 0.836 X 300 plus 0.25 pi times 28 squared times 2 times 600 times X minus 70 over X. Shift solve. So let's wait. So yung value ng C natin is equal to 114.76. So yung A is equal to beta 0.836 times C. So therefore, yung A natin, or the depth of compression block, is equal to 95.94 mm. So nasagutan na natin yung question number 1. So A is 95.94 mm. So now, let's go to question number 2. So, determine the design strength using 0.9 as the reduction factor. So, MU. So, check muna natin kung 0.9 yung gagamitin natin as reduction factor. So, tignan natin dito sa 2015 code. Yan. So, when the strain of the steel is greater than 0.005, so that's the time na nagagamit tayo ng 0.9. Otherwise, eto. So, we have this and this one. Kung nasa in between siya, ng 0.02 or yung maximum yield strain for compression and between dito ng 0.005, itong gagamitin natin. Kung mas mababa pa siya 0.002 or yung maximum compression strain, so ito yung gagamitin natin. So i-check natin. Check natin yung value ng strength reduction factor phi, kung yun ba talaga ay 0.9. So galing dito sa stress strain diagram. So by ratio and proportion, yung yield strain natin ng steel is to D minus C equals the maximum strain for compression block of 0.003 is to C. So, by substitution, the yield strain of steel is 0.003 multiplied by D minus C. So, that is 330 minus, yung C natin is 114.76. So, minus 114.76 over C. So, sa calculator natin, yung value ng yield strain of the tension steel is 0.003 times quantity of 330. So, that is D minus C over C. So that will be 0.0056. And this value is greater than 0.005. Therefore, we use phi equals 0.9. So now, kuya naman natin, since kanina, compression still does not yield, and ito yung Fs prime is equal to the strain of steel multiplied by the modulus of elasticity of the concrete. So, ito yung formula niya kanina. Solve natin yung Fs prime. We have Fs prime equals 600 times C minus 70 over C, and that is 600 times 114.76 minus 70 over 114.76. So Fs prime is equal to 600 times the quantity of 114.76 minus 70 over 114.76. So we have 234.02 megapascals. So that is way less than 415 MPa. Meaning to say, hindi nga mag-yield yung compression steel dahil hindi niya ma-reach yung maximum stress na kaya ng steel natin sa compression bars. Now we have the value of the Fs prime. So pwede na tayo mag-solve ng ultimate moment. Mu is M1 plus M2 multiplied by phi. So yung M1 natin could either be C1 times the moment arm plus C2 times the moment arm, or T1 multiplied by the moment arm plus T2 by moment arm. So, eto na lang yung gamitin natin, C1 and C2. So, M1 is equal to C1 multiplied by the moment arm of D minus A over 2. And that is 0.85 Fc prime AB times D minus A over 2. So, by substitution, 0.85 multiplied by 30 times yung A natin kaninang nakuha is 95.94 times B of 300 minus D is 330 minus A over 2. Tapos divide natin sa 1,000 squared para maging kilonewton meter. So M1 equals, so we have 0.85 times 30 times 95.94 times 300 times the quantity of 330 minus 95.94 over 2 times 1 over 1,000 squared, and that is equal to 206.99 kilonewton meter. Now for M2 is equal to C2 times D minus D prime. So yung C2 natin is AS prime, FS prime. So that is AS prime, FS prime times D minus D prime, and that will be equal to pi over 4 times the diameter of 28 squared multiplied by the number of bars 2 multiplied by Fs prime, yung kanina 234.02 MPa times D minus D prime multiplied sa 1 over 1,000 squared para kilonewton meter yung unit natin. So M2 is, so that will be pi over 4 times 28 squared times 2 times 234.02 times quantity of 330 minus 70 divided by 1,000 squared, and that is 74.93 or kilonewton meter. So now meron na tayong M1 and M2. So the ultimate moment MU is phi, so that is 0.9 times M1 plus M2. So your ultimate moment is equal to 0.9 times the quantity of 206.99 plus 74.93, and that is 253.73 kilonewton meter. So ito yung MU natin. So we have 253.73 kilonewton meter. Now, number 3 na tayo. So determine the live load at midspan in addition to a dead load of 20 kilonewton per meter, including the weight of the beam if it has a span of 6 meters. So yung live load natin is concentrated at midspan. Therefore, we use the formula for the maximum moment for a concentrated live load at midspan. So for number 3, so sa dead load natin, maximum moment natin is equal to W L squared over 8, where W is your dead load. While sa live load, since it is concentrated, yung maximum moment natin is equal to PL over 4. And since ultimate moment, so multiply natin siya by, sa live load, this is 1.6. Sa dead load, we multiply it by 1.2 as per NSCP 2015 specs. Therefore, yung MU natin, 253. So, MU equals the dead load times L squared over 8 times 1.2 plus the live load of PL over 4. So, UP natin yung live load times 1.6. So now, let's substitute 253.73 equals yung dead load natin 20 times the span of 6 squared over 8 times 1.2 plus the concentrated live load. So yung P or LL multiplied by 6 over 4 times 1.6. So live load natin is equal to, so that is in kilonewton. So shift solve na lang tayo para mabilis. 253.73 equals 1.2 times 20 times 6 squared over 8 plus 1.6 times 6 times yung natin, yung concentrated live load, then over 4. So shift solve. So yung concentrated live load natin is 60.72 kilonewton. So double check natin. So 1.6 times PL over 4. Ito, 1.2 times WL squared over 8, 53.73. Okay, so yun yung sagot. Yung concentrated live load at midspan is 60.72 kilonewton. So that is 60.72 kilonewton. So nasagutan natin yung sample problem. Hopefully may natutunan kayo sa video na to. So thank you for watching. Abangan yung susunod natin na video for this subject. So keep on following and subscribing my channel.